Picking up from the last video, we were creating our own custom 3D mesh objects. However, we ended with just understanding what the vertex positions were, as well as what the indices were. In this video, we're going to explore a few different vertex attributes. That is data that can be provided per vertex that will enhance our model in some way. One method of enhancing our model is by providing color information per vertex. Another thing we can add to allow our surface to become more interactive with the lighting around it is to provide a normal for each vertex. To do that, though, we need to create a three-dimensional object, because the two-dimensional ones are so simple that many times you don't get to see the real results of normals with them. So we're going to create something very simple. We're just going to create a roof of a house. We'll create 4 points for one side, and then an additional 4 points for the other, and then we will connect them similar to this. Now what you'll notice is that the face, that is the polygon created by declaring these vertices, have a surface pointed in different directions. Here you can see the arrows pointing off into either direction. So these vertices on this side are going to want to point in this direction, and these vertices on the opposite side will point in this direction instead. Now if we use quads, we will define 1, 2, 3, 4 points, and another 4 points for the other side. If we decide instead to use triangles, we will have to define this triangle, and then the same 2 triangles on the opposite side for this face. Why would we want to split this up into 2 separate triangles as opposed to just using a single quad? Well, it has to do with what you're interested in making happen. For instance, I said that you could apply vertex colors, right? Well, what if you wanted this side to be a different color than this side? So say you wanted purple over here. Well, we would need to define vertices at these locations that are purple, that is, they have a purple color, and vertices at these locations that have a red color. What it comes down to is that right here, while it might look like it's a single vertex, in reality we need 2 vertices here. Now in some systems, you could actually create indices not only for your vertex positions, but also for your colors and normals and other information as well. That is not the case inside of Unity. If you want to specify a separate vertex attribute, that is a separate color for a vertex, then say another color that you have at this location, you do need to specify this vertex position twice. So let's go ahead and say that the center of our object is going to be right here. That's y-axis, and then we'll have our z-axis coming out, and then our x-axis coming off to the side. Now this is a right-handed system. If you line up your thumb with the x-axis, your index with the y, you'll see that z is coming out at us. So if we wanted this to be left-handed, we could do this instead, make this x positive, and then of course lining up your thumb with x positive, your index finger with y positive, which would be going up here, z positive would then be coming out this way for a left-handed coordinate system. Let's just figure out what these points are going to be. Say this one here and this one there, because if we can know what these points are, we'll say that this object is symmetric right here, and we can just of course negate it across that z-axis. So let's try to keep things within a space of 1 unit, in which case this is probably going to be some sort of a 0.5 in the z direction, and it is going to be probably a 0.5 in the x direction as well. So we have that, and then in y it will be 0. Now over here at the top we have a slightly different situation. It's also going to be that same 0.5, positive or negative is up to us, but then we're also going to end up having a 0 on the x direction since it's right in the middle, and then we will be, 1 unit high. So this means we will span from negative 0.5 over here to positive 0.5 over here. So let's make this happen. Let's go back to our scripts folder and we'll have our triangle script from before. Let's go ahead and right-click Create and create a new C# script and call this Roof. Double-click it to open it. If you still happen to have your triangle script, we can reuse some of this code to speed things up. Now you could create an abstract class by taking this information and creating this generate mesh as an abstract method and having your particular class fill this in. So why don't we go ahead and actually do that? So coming back over here, we'll right-click, go to Create, and create a new C# script, and let's call this mesh generator. Now let's make sure we spell it right. Rator, there we are. Open it up, make sure we spelled it right here as well. And what we're going to do is make this an abstract class. So public abstract class mesh generator mono behavior. Coming over to our triangle, we know things that we were using that we'll continue to need to use when we generate our own meshes are things like the mesh filter and the mesh renderer. So why don't we go ahead and take these and put them in the mesh generator class. Coming back over here, we'll notice we did a lot of work with those mesh filters over here and here. So we might as well take all that information, copy it, and bring it into our mesh generator class. Start requires that we have a generate mesh method. So let's go back to triangle, copy generate mesh. The only difference is we're actually going to remove the code inside for mesh generator and make this abstract. Paste this here, make this abstract, and remove the code from inside. Put a semicolon on the end. Our expectation is that whenever a class inherits from mesh generator, it will do this start method, and what will happen is when it gets here, it will call generate mesh, which should have been filled in with whatever code you decide for your particular child class. Now let's go ahead and get rid of update, since we're not doing anything there. Let's go ahead and make this public virtual void start. I've stated that it's virtual so that when child objects inherit from this particular class, they will be able to override start if necessary. So let's modify triangle first to get that working. Triangle will no longer inherit just from monobehavior. Instead, triangle is going to inherit from mesh generator. Generate mesh, the method we made earlier, is going to give us a little bit of an issue. It's going to say, hey, to make this override your prior implementation, go ahead and add the override keyword. So public override mesh. Now we already have the code here to make this happen, so that'll work just fine. Now there's one thing that's bothering me a bit, and that generate mesh really probably shouldn't be public. Generate mesh is only going to be called by the start method within this particular one. Therefore, we can make this protected. So let's go ahead and convert this over to protected. Just make sure that after you do that, we come back here and make the abstract class version also protected. Now coming back here in start, we also get a little bit of a warning stating that, hey, did you mean to override this particular implementation? And yes, I did. So let's do a public override void start. Now all of this code was already done beforehand, so we can get rid of this. And let's go ahead and make sure that we call start for the base class. So let's do base.start. This code will then fire off that was inside of here because it's part of our base class. And if we decide that we need to add additional code in start below this, we can go ahead and add whatever we'd like to our heart's content. Now that we have triangle set up to work with our mesh generator class, let's jump back into Unity, check out our triangle, see our script, look for any warnings first. Here we have triangle mesh filter is assigned, but its value is never used. Doesn't matter. Let's go ahead and hit run now. And there we are. We have our triangle still functioning as we expect. However, we're using our abstract class to help us out. Let's go ahead and create a new empty game object and call this our roof. Let's go ahead and click and drag our component onto roof. Back in Visual Studio, let's go ahead and move triangle off to the side. We'll keep it open on the side for now in case we need any reference. Roof is going to inherit from our abstract class, mesh generator. Now it's going to complain to us because we have not implemented the abstract member generate mesh. Go ahead and click on this and tell it to implement it for you. Feel free to delete the throw new system not implemented exception. We'll be filling this in with code shortly. We also have this issue down here with start. Once again, let's go ahead and make this public and override. And we'll go ahead and call our base class functionality. Now we're getting an error up here, and that's because we have not returned a mesh object yet. Now what we can do is come over to our triangle class and reuse some of this. Now regardless of what object we're creating, we're always going to probably end up with vertex and index lists. One choice might be to create these lists and put them in mesh generator, the abstract class, since we probably will always be generating them. Or we can just copy and paste them and put them in each class as we see fit. We now need to add our vertices. We saw that we needed 4 per side. So we'll do that. We'll do another 4. Let's use comments to make sure we understand what's happening. We'll say left side and right side. Now on the left side, as we see here, we're going to need a negative 0.5, 0, and 0.5. So let's go ahead and put that in, negative 0.5, 0, and 0.5. Make sure they are floats. Our next point would be over here, in which case it would then be a negative z. So let's go ahead and copy this line here and paste it right here. Move this out of the way and make this negative. Now we need to do the next point, which is above it. So it's going to be this same point. However, it's going to be up in the y-axis. in which case we're going to do 1.0, and it's going to not have any x component. We can get rid of that here. However, we will be in the negative z. And then the next point is going to be similar once again, except we're coming back around. So we're also going to have a 0 in the x because we're still zeroed out in the center. However, we're still up in the air. However, we are now positive in the z direction. Now for the right side, it's going to be very similar as well. We just need to make sure that in our heads, we keep this all straight. So now, if we were coming from the other side, correct, we could either infer that this point here would be the same as this point back here if looking at it from this side. This side over here is also going to be going in a clockwise fashion. So if we're looking from this perspective at this surface, the surface will actually look like this. And let's label this point back here as 1, 2, and then 3, and then 4, right? This would then look like 1, 2, 3, and 4 from this camera right here. And then we're also doing the clockwise rotation like this. Therefore, we're going to be starting here, moving to here, moving to 3, moving to 4, and then we're done. Coming back to our code, we're in the negative z, we're in the back side, we're at the ground, and we should be positive in the x. Now if we take this, copy this, and paste this to the next line, what we'll notice here is that we're moving over to the positive z. But everything else is the same. Then we're coming up to the top now, in which case we're back again in the positive z side. However, we're 1 up. And then when we come down to the other part, we're actually going to go to the negative z. And with that, we've defined all the vertices we need. Now we need to create our index list for these vertices. So let's do indices.add. And what we want to do is we put these in pretty much the correct order. So we're starting here and we're going around. And that makes our life a little easier when we're doing our indices because all we need to do is do index 0. And I'm going to put 0, 1, 2, 3, 4, 5, 6, 7. So you see the indices and you can follow along and understand what's happening a little bit easier. So we want index 0, and then we're going to want a few more, then 1, 2, 3, 1, 2, 3, and then we'll grab the same set of indices and put these here, and we'll then do a 4, 5, 6, and 7. So there's our index list for each side. Now with how I've done this, what you'll notice is that we need quads to make this work. So if we wanted to do triangles instead, we would need to split this up into a few more sub-items. For instance, we would do 0, 1, 2, and then we want to continue with this clockwise representation. We would then do 2, 3, and then 0. Now I want colors at each of these locations as well. Many times, it's more convenient to keep these items together rather than splitting them up into separate items like you see here. That is, to keep the color information with that particular vertex information as well. In which case, we can do a list. We can do a color. Let's just call this colors is equal to new list of color. So down here, we can do colors.add. Or if you wanted to, you could take this and put this right here. This is another popular way of keeping the data together on a single line. In which case, colors.add would need a color. We can do a color dot, and Unity has several built-in colors you can see here. So let's start with red, and then let's do a few more colors. And we'll do green, blue, and we'll do yellow for one side. And then we can take this same information, paste it over here, and we'll do different colors on the other side. So we did RGB and then yellow. Actually, let's make this black instead. How about that? And then what we'll do here is do colors, but we'll do, let's see if they have cyan, CY, yellow, and magenta, and then black as well. CYMK, RGB, black. Now that we've created our vertices and our colors and our indices, let's go ahead and generate our object and see if we've gotten it right so far. Once again, we can come over to our triangle example, and we can go ahead and grab our mesh equals new mesh, and we can use set vertices, and then we can go ahead and set the indices as well, and return the mesh. So copying that, pasting it here. Coming here, mesh.setVertices, we set to be vertices. Mesh.indices, we're going to set this to quads this time. Submesh is 0 because we're not dealing with them. And then we're also going to go ahead and do mesh.setColors. And then what we want to do is pass in our color array. If we move down through here, we'll notice that we have a couple different methods. In this particular case, we can pass in a list. So let's grab our colors list, pass that in as well. And then our mesh gets returned. Let's go back to Unity and run and see what happens. So I'm going to go ahead and move our triangle object somewhere off center. I'm also going to select our triangle object. And here I'm going to press this small area right here in the inspector. This allows me to set an icon for that object so I can find it. Game objects without anything attached to them are invisible. So it's a good idea to put icons on objects to find them later. Let's go ahead and put a diamond on the triangle. It doesn't look like anything happened. However, if we come up to gizmos and move this 3D icon to be larger, you'll begin to see the diamond right there. I'm also going to go to roof. Let's do the same thing. And I'm going to give this one let's do a red diamond. Let's go ahead and hit run. And here we can see what happened. We have our object. However, it looks like we constructed it backwards. As you can see here, we're seeing the opposite side to what we want to create. In addition, you'll notice we also have material issues because we have not associated a material object with this. Let's go ahead and fix both of these problems. So coming back here, we can do this in two different ways. We can either just change how our indices are set up, or we can look at how we slotted these individual vertices in here and make these work with the current indices we have here. So here at the top, what you'll notice is I'm in negative x, which is fine. All of this side should be negative in the x, and all of this side should be positive. This is correct. The only part that doesn't seem to be correct is where we have our z-axis coming out. Now, if we take a quick look at Unity in world space or locally here in this particular object, what we'll notice is that z forward is this direction here, and x positive is this direction here. When I wrote those numbers down, I had my x-axis and my z-axis flipped. That is, I was using a right-handed coordinate system. Let's see what happens if we flip things, if that fixes it. Now coming back here, as I mentioned, it seems like my z's are flip-flopped. An easy way to fix this is just to change the sign of each. We'll go ahead and hit save. And coming back here, let's clear this out and hit run. And now what we'll see is that it appears that nothing exists. However, that's just because we're looking at it from the wrong side. Coming over here, we'll notice that this side, which we just fixed, is rendering properly. However, this side, which was facing the wrong direction, appears because it's still facing the wrong direction. Let's go back and fix the other side as well. Coming over here, once again, all we need to do is swap our signs. Here we are, and there we are. Hit save. Now actually, I'm noticing we're getting a couple warnings or errors here, and that has to do with the fact that we left some code in our triangle class. Let's clean this up really fast before moving on so that these go away. I don't like to leave errors ever before moving on, and warnings, I like to tidy them up at least by the end of my project. When in doubt, read what it says. The same field name. So ignore field if you don't understand that. Just the same name is something, if you don't understand this, multiple times in the class or its parent class. So we have the same name multiple times in the class or its parent class. That is all you need to understand. The same name. If it's the same name, we're dealing with variables or functions, right? So let's take a look at Mesh Generator because it said it could be the class triangle or it could be the parent class. What is something that was copied from one side but not removed from the other? That is the declaration of these variables here, mesh filter. I do not need to do this again under triangle because it implements Mesh Generator. So get rid of those, hit save, and come back to Unity. Give it a few seconds. Let's clear it and then come back. Make a inconsequential change, maybe add a few new lines, save it, come back over here, and see whether or not any errors pop up. Nothing appears to be popping up, so I think we're okay. Now our next issue, even though we fixed this one, is the fact that we don't have a material applied to our object. We'll be getting to materials shortly when we start handling textures. However, for the moment, let's just create one to make our life easier. Go to Assets, right-click, Create, and generate a new material. Let's call this Roof. Now right now we're using what are called vertex colors. Vertex colors were very popular a long time ago. Not as much these days, unless you're doing specific things, sometimes with terrain or other things. Now we're supplying vertex color information. Therefore, we actually need a shader that's going to listen to that vertex information, the color component. Things like the standard shader inside of Unity, which are great at rendering things somewhat realistically, do not listen to things like vertex color information. Therefore, even if we were to apply to roof that particular information, it wouldn't work properly. Therefore, we need to make sure we choose a shader that will allow for vertex coloring. So going under Shader, Standard, let's go to Unlit and choose Color. Now here, this provides a main color, but does it provide individual vertex color information? If we come over here to this gear to select the shader, we can take a look at the shader. We'll notice that there's only one incoming property, and that's the main color. If we go ahead and hit Run now, and select our roof, and drag our material into the Mesh Renderer material slot here, what you'll notice is that the object does render. However, it's all black. Even if we rotate this light source here, we'll notice no individual vertex color. Now it is being lit, although it's being lit improperly. Each of these vertices is being given in the shader a default value, most likely negative or positive Z in some direction for the normal. And you'll notice that as I move this light source around, even if I do it directly to fall on both sides of the object, vertically straight down, it's still not lit up. Once again, this is because default values are being used by the shader to calculate the normals because we did not provide them. So what we want to do is use a shader that is going to allow us to work with vertex color information. So select the material, go to Shader, and let's try Mobile. So let's go to Shader, and looking at these different variations, let's try Sprites and Default. Now let's go ahead and hit Run. And once again, we lose that association, so we need to add that back. And what you'll notice here is it's not perfect. Because we're using sprites, they typically have some sort of transparency involved with them. And we're getting some of that here, as you can see. However, it does provide the ability for us to view the different colors that we applied to each part of that object. And the important thing to understand is that vertex here was a single vertex with a color, cyan. Over here was another vertex with yellow. However, in the process of these vertices going through a shader, a programmable shader, to calculate where they should be and what they are, those single points were turned into primitive objects, a quad in this case, and the values were interpolated over the surface. It's not a hard yellow up to the midpoint and then it switches over to cyan. Instead, it's a gradient of color. And what you need to know here is that for a vast majority of parameters passed into the vertex shader, they are going to be linearly interpolated over the surface so that you get a range of values from one location to another. And in order for this magenta color to have not bled out onto this side, we needed to supply two vertices for this particular point in space. One with the magenta, one with black. Same thing with the other points up here. And this is going to be doubly important in a second when we add normals, because we need these vertices over here to all say they're facing off this direction, and these vertices over here to say they're facing off this direction instead. I'm getting tired of associating that material every time, so let's fix that, and then let's add our normals to the surface. Coming back over here, let's move our triangle out of the way, go back to our roof. So what I want to do is first create a public material. And what I want to do is, inside of Start, after this object has been generated, I'm then going to associate the mesh renderer with that object. So we had defined a variable mesh renderer inside of mesh generator. However, because we did not use an accessor on the front of it, it will automatically be private. Therefore, we can't access that through our roof child class. So let's go ahead and make this protected. This way, our child class can access these variables. Coming back over to roof over here, we can then do this .meshRenderer.material is going to be equal to the material that we assigned, assuming material is not equal to null. So hopefully someone sets that up in the inspector. Now let's check that this works. So here's roof, and we can see that we have a slot now for the material. We can drag that material here, and if we click Run, we now see it's set up properly. Now that transparency is bugging me, so let's choose a different shader. Coming over to roof, before we use sprite, let's just try simple unlit this time, and color. Now let's hit Run. And in this case, you'll notice that we're just getting a flat color on the surface. Here it is right here. So it is ignoring the vertex color information. Let's try a different one. Let's go to particles and let's just do standard unlit. Now in this case, it's taking the red, which we have chosen here, and it's multiplying it by whatever the colors we provided. So that we can see this as it normally is, we want to choose white. We'll be getting more into color and multiplication and how you blend colors together when we get further into shaders, as well as when we talk about textures. What you need to understand here is that we're providing two different parameters to work with. The first, of course, are our attributes per vertex, which is color information. The second is this albedo color you see here. The color here is multiplied by whatever color you select here. Therefore, if there is no red component in the color we selected, that is, if we move this over here, it will turn black. Because 1, which would be fully red, times 0, which is no red at all in that particular point, would give you a value of 0. Same thing if we choose this to green or blue. You'll notice how it changes. Or if we change it to be some value in between those, you'll see that we get different parts coming alive. Let's jump back into our code and add those normals. Now I personally don't usually like doing it this way. While it does keep the vertices and the colors and all their other information in one location, it does make it difficult to copy and paste things because selecting multiple lines like this, even if you use Control or Shift or whatnot, doesn't really work. Therefore, I'm just going to make another section at the bottom. Let's create a new list, and this one is going to be also of type vector3. Let's call this normals equals a new list of type vector3. And we'll do normals, 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 normals. Add, and then we will provide normals for each surface. How do we calculate what the normal should be? It's a very good question. Now, if we want to, we can use the cross product to do this automatically. If we had one part of the surface, like here, and then we know that we have some normal shooting out like this off the surface, right? To figure this out, we can use the vertices that define the surface. So we have a vertex, for instance, here, here, and here. Now for the moment, I'm going to assume that these are all planar. If they're not, because we have 4 vertices, you might need to split it into a triangle, determine what the normal is on this side, and then determine what the normal is on that side. We'll define one vector, such as this one here, and then we'll define another vector, this one here, going from this point here up to that one, and this point to that one. When you take the cross product of these two vectors, assuming unit length, you'll end up with another vector perpendicular to these two, which is the normal of this surface. Now, if you did use triangles, you could also do that by using these 3 points, doing the same thing, and then once again getting a normal that shoots out of that side as well. So let's make this happen. Let's first do our cross product stuff. So let's do vector3 temp is going to be equal to, and what we're going to use are these vertices to define this directional vector. So assuming that vertex 0 is our central point, we can use 2 other vertices to define the rest of it. So we can take vertex 1 and subtract that from this one here. And this is, let's say temp line, this is going to be our vector or our line if you want to think about it. That'll be 1 and this will be 2. And then this one is going to be this point here minus our starting position once again over here. Those stay the same. Okay, so those gives us our 2 lines emanating off that 1 point. Now we need to do the cross product. So let's do vector3, just temp, vector3 dot cross, and then we'll specify the left-hand side and the right-hand side, temp1 and temp2. If this ends up being the wrong direction, you can just flip them around afterwards. Now that we have defined this temporary normal, actually maybe calling that normal would be better, we can create our list of normals because all of the vertices are going to be using this same normal. Now one thing we do want is to probably normalize this. So let's do dot normalized. Now we'll take normal and paste it into each of these. So I'm going to grab these lines of code here, copy this, bring it down here, under left side, and under right side, paste here. Now we already have temp1 and temp2 declared, so we don't need to specify the type for them. We do need to change this part here and this part here. I'm going to go ahead and index into our vertex list. So let's do vertices 1 and vertices 2 here, and we'll be using vertices 0 and vertices 0 here. And hopefully you caught that this is incorrect. This is how you would do this for up here. What we want to do is use these indices here. Remember, it's one list we're adding these to, so don't get confused. So what we want is 4 for 0 and 5 and 6 for the other two. Now with that, this line still works just fine, and we add an additional 4 normals. Now we just need to add the normals. Let's go to mesh.setNormals, and then once again we'll pass in our normals list. Coming back here, let's hit run, and here what we'll see is our object, and nothing looks different. Well, one reason for that is if we check our roof, we do have particles, standard, however, it says unlit. So even if we have a light source in the scene, it's not going to matter because this is not processing lighting. What you can see here are the required vertex streams. These are the attributes. What makes this shader work? Well, position, color, and UV are required. Let's ignore anim for right now, animation. Color, though, is what we are providing, color information per vertex. Let's switch this to a different. Once again, let's go under particles. Let's go under standard surface instead. And what we'll notice here is that it changed momentarily. If we take a look at our light source, let's move this light source down here. And once again, go to Gizmos, 3D icons, and make that really small. Notice how these rays are facing this surface, and that surface appears lit and bright. Now come over to the other side, and you'll see that this side is dark. Now let's also go to the light and make sure that this is pure white light as well. And if we go back to the material, let's also make sure that this is pure white as well. And this will make more sense now, because before we were mixing colors, which was causing different parts of it to appear incorrectly. Colors are multiplication. If this side is 0, that is no light, and this side is 1, 100% light, any color over here multiplied by 0 will produce black. Whereas any color over here is being multiplied by 1, that is 100% lit. So with this, we've shown you how you can create other types of vertex attribute information. Here we've created buffers for color as well as for the normals.